Here are a couple functions that you should really know how to sketch.
Now, even if you don't feel confident, go ahead and try and sketch these on your own.
We'll start with our first set of functions. What we notice is that our first graph y equals x is just a nice linear function in a straight line. Our y equals x squared, of course, a quadratic or a polynomial. This would have this nice U shape. And our third function, y equals x cubed, this is going to have what we kind of refer to as an S-shaped graph. So it's a cubic graph. It'll look something like that. Moving on to our next set, the first function we see is an absolute value function. Absolute values have this V shape to them, something similar to this. What we should notice with this graph is no matter if the x value is negative or positive, as long as they have the same magnitude, it will produce the same output or the same y value. The next function is the reciprocal function, y equals 1 over x, also known as a hyperbola. Note that the reciprocal function has origin symmetry, which means it's symmetric about the x-axis and the y-axis. We also have the square root function, y equals square root of x. Note that we do have a value at 0, so when you take the square root of 0, you'll get 0 out of it, but we don't see any part of the graph over here in the negative x values. That's because we won't produce any real values by taking the square root of a negative number. Now we look at our trig functions. We've got sine and cosine plotted here. Note that these are sinusoidal functions, so they have this wave shape. We know that cosine at 0 is 1, so we get our peak there, but sine at 0 would be 0. That one doesn't get its peak until pi over 2. So these graphs are just a shifted version of one another. We should also know the shape of our tangent graph. Note with our tangent graph, we have this S shape and it pushes to positive infinity and negative infinity at these asymptotes, which occur essentially at pi over 2, negative pi over 2, and then any pi multiple after that. Last but not least, we look at the log and exponential functions. Recall that logs and exponentials are inverses, which is why if we were to look at this y equals x imaginary line here, they are symmetric across that. We should also note that the exponential has this asymptote at y equals 0, or the x-axis, which means that this gets closer and closer to 0 as we go to negative infinity, but it doesn't actually reach 0. A similar logic applies here on the y-axis, or x equals 0, where our natural log graph gets closer and closer and closer to the y-axis as it pushes its y value down to negative infinity, but we never actually get to the y-axis. Keep in mind that all these sketches were just for the base or the parent function. If we had a transformation on that function, we would just adjust the base graph to fit our needs.